Hi, today I'm going to talk to you about different kinds of thermometers. Now, we're all pretty much familiar with this. This is a glass thermometer. It has a liquid inside. Sometimes it's mercury and sometimes it's alcohol. This was invented by Daniel Fahrenheit. And how it works is you warm up the bulb and the liquid expands and wow, you can see it rise. Look at that. It went from 20, 21, 22, 23, just from the warmth of my hand. More modern is this one. This is an electronic thermometer. It has a probe on the end of this wire called a thermistor. And watch what happens. Okay, the temperature is at 21 degrees, and you hold it in your hand, 22, 23. There are dissimilar metals in this, and their conductivity changes with temperature. This is called an electronic thermometer with a thermistor. This right here is an infrared thermometer. It works by measuring the infrared rays coming off of objects. There's a detector in the front, right here, that measures infrared radiation coming off of something. We call that heat. So watch, I'm going to point it at my hand. The little dot tells you where it's pointing, and it reads about 30.8 degrees C. Now this is called a bimetallic strip thermometer. You typically see these on large outdoor buildings and sometimes in the oven. This came from my kitchen. How it works is there is a bimetallic strip coiled up in the back, and it changes its shape with temperature. And I'll show you how it works. What I have here is a bimetallic strip thermometer. How it works is there are two different metals bonded together that expand and contract at different rates. Look what happens when I warm it up. What's going on is one of the metals is expanding faster than the other. The one on the top is expanding faster than the one on the bottom of the strip. Look what happens when I cool it down. Now it's bent the other way. The one on the top is contracting faster than the one on the bottom, causing it to curl up.
So the first thing we have here is 3 containers of ice, and they all are showing that 3 thermometers. First thing we're going to do, are they all showing the same temperature? So are our thermometers consistent? This particular thermometer is at 0 to -1 degrees. This thermometer is showing it at 2 degrees. This thermometer is showing it at 2 degrees. And then this, so those are the 3 thermometers, one showing a little bit less, and there is some environment here. You have air around the ice, you have water, and what are you actually measuring? The ice, the air, the water, or some combination of the 3. Okay, we have 3 thermometers, all the same type, so how good are they? Are they consistent? This thermometer says it's about 0 degrees. Go to the next one. This thermometer is also in ice water, and it says +1 to +2 degrees. And this third thermometer in ice water, or should say just ice, and it is at 0 degrees. So these thermometers are good to ±1 to 2 degrees, not any better than that. Here's another type of thermometer. This is called a thermistor, and there are a combination of metals in the end here, and the conductivity through the metals changes with temperature. And so if we know that the temperature changes conductivity, and then we can record that conductivity, we have a good estimate of the temperature. So if we put it in the ice, and we can see that it is at about 3 degrees. Let's say get a little deeper in the ice. See if we get it a little more covered up down here, and it goes down to 2 degrees. So again, it is fairly consistent with the other 3 thermometers. Let's try another thermometer. Okay. This is an infrared thermometer. You can see the laser is on the ice, and it's measuring at -1.6 degrees. In this demonstration, we have just straight ice in the center. We have ice water on this side, and then salt plus ice over here. This is rock salt, small little chips of solid salt crystals, just like in a salt shaker. But instead of small tiny crystals, they're much larger crystals, so that you mix this with the ice to get a nice cold mix to make your ice cream. In this demonstration, we have ice alone. Again, it's at 0 because we're measuring the air and water and the ice all in combination down here. In this second beaker, we have ice water, and we're measuring the temperature essentially of the water since the thermometer is surrounded by water. And it again is also about 0. So both water and ice can exist at 0. In this third container, we have salt and ice in a 50-50 mix, and its temperature is all the way down to minus 15 degrees Celsius. That's pretty cold. And that's why we use it to making ice cream.